Hey, welcome to a new episode of Data Exposed. My name is Pedro Lopes. I'm a program manager in the SQL Server engineering team. And today I'm going to be talking about the intelligent database, specifically intelligent query processing in SQL Server 2019 and also Azure SQL Database. So let's get to it. SQL Server 2019 introduces groundbreaking query performance enhancements under the intelligent query processing family. These make up the latest on Microsoft's mission to make sure that critical parallel workloads improve when running at scale, while remaining adaptive to the constantly changing world of data, as data moves in and out of databases. In this video, I'm going to give you a quick overview of the intelligent database world that really takes a leap forward with the upcoming SQL Server 2019, and introduce you to a number of features that we'll dive into deeper in other videos in this series. Intelligent query processing in SQL Server is available by default on the latest database compatibility level setting. That means that after you upgrade, these can be available just by flipping the switch to use the latest compatibility setting. Intelligent query processing also delivers broad impact that improves the performance of existing workloads with minimal implementation effort. This really means that most times there is zero need to refactor your code. And intelligent query processing improves critical parallel workloads when running at scale. And as data flows in and out of your database, we will adapt to that and maintain a level of predictable performance. For example, by introducing a feedback mechanism into the memory usage, we can ensure that your workload executes in a predictable way. If a given query execution would maybe take up too much memory, we can correct it and increase the concurrency factor of your database. If a given query execution does not get enough memory and ends up using additional I/O through what is known as a spill, then we can also find that and correct the situation so that the operation executes in memory and performs as expected in subsequent executions. This feature is now enabled for all execution modes in the database engine. Batch mode for more data warehouse and analytical workloads, and row mode for your critical OLTP workloads. And we're also going into new areas, which we're calling approximate query processing. For example, think of a scenario where a railroad company keeps track of numbers of tickets that are bought and used in the entire railroad system. And they keep track of this in order to implement some flow control measurements when it's needed, perhaps by adapting the schedules of the trains or the number of trains in the system to meet the needs of the moment. This information is also updated in a dashboard that folks in downtown Central can take a look at. Now, in this scenario, part of the workload will be surely to run a query that's constantly looking at obtaining the row count of all the tickets that are sold and used. And this is probably like coming from a very large table, perhaps with billions and billions of rows. Now, this recurrent query would normally take up considerable resources on your server, namely memory. And if it's executed repeatedly, can really affect the performance characteristics of your database. However, in this scenario, the railroad company doesn't necessarily need an absolute count of all the tickets that are sold and used, but a very high approximation is enough to trigger all the required decision-making. This is where approximate count distinct comes in. By allowing a query to repeatedly obtain the approximated count of tickets sold and used without the severe impacts to your database performance that your normal count query would take today. And by enabling batch mode on row store, we effectively unleash the processing mode that's especially optimized for analytical workloads over any table on your database. This means that even for scenarios where a column store index would not be an option, the database engine can still execute this in an optimized way. And in turn, this opens the scope of features like adaptive join to be used by your workload. Adaptive join, which is only available in batch mode, can now be leveraged across all the tables and most of your workloads. And we also tackled some of the most recurrent anti-patterns that become a problem for many SQL Server workloads. The use of table variables and the use of scalar UDFs, for example. And now we can unlock new levels of query optimization that were not possible until recently. All of this we'll discuss deeper and with demos in upcoming videos in this series about the intelligent database, specifically intelligent query processing. But if you want to know more about this today, then please go to this aka.ms WEC IQP URL, where you see all the documentation on intelligent query processing in SQL databases. If you want to experiment some of these by yourself right now, we also have demos that you can look at if you go to our GitHub repository, and the short URL will be aka.ms/IQP-demos, where you'll be able to look at all these features and experiment by yourself. So again, take care, and I'll be talking to you soon.